Hello, everyone. Welcome to Chapter 1 of Week 1, Chemistry in Our Lives. In this chapter, we are going to discuss three major things. We are going to talk about chemistry in our lives and how useful it is to know basic chemistry knowledge or fundamentals of chemistry for different fields that we do. We are going to describe the scientific method, the different components of the scientific method, and give examples. And then we are at last going to talk about the proper study strategy for this course. I will give you some advice on how to study and prepare for Chemistry 102 in order for you to succeed and get good grades and pass this course and leave this course being well equipped and knowledgeable of the content um, that we are going to cover. Chemistry in our lives, chemistry is a big part of our lives. It's all around us, it's within us. The human being is composed of chemical molecules. It's around us in the material that we encounter. Air, for example, is composed of chemical molecules. So chemistry is everywhere. Now, scientists in specific are required to be well equipped with basic chemistry knowledge as well as more advanced chemistry knowledge in order for them to do their job properly. And for example, here I have forensic scientists and clinical scientists, that both scientists are utilizing basic chemistry principles to perform their jobs. Forensic scientists analyze bodily fluids and tissue samples. Clinical scientists analyze blood samples. And in both cases, the scientist is required to perform chemical calculations. The scientist is required to have basic knowledge of the chemical molecules, the composition of solutions, also have basic knowledge of how to carry out a chemical reaction, what to expect as a product of the chemical reaction, and how to analyze and deduce or conclude with an outcome from the result of this chemical reaction. Now, for me, chemistry was not just a field that I had to learn in order to pursue my career. It was something that I was always so fascinated about, and I always found it so interesting and exciting, and I was excited to learn about it because I was introduced to chemistry when I was in high school, and even before high school in basic elementary science, you are introduced to chemistry. But it was in high school when I realized that I was just so fascinated when I learned about these complicated little tiny molecules called atoms or matter, how well designed and how well organized these structures are. So it was fascinating for me. I wanted to learn more. I wanted to discover more. And it was most importantly what really drove me to want to learn more. It was this sense of awe that I was always getting as I learned about the beauty of our Creator who created all of this. This beauty is manifested in all of these things that we are going to learn and all of the topics that we are going to cover in these tiny systems that work so intelligently. Um, Chemistry, you see chemists working in the laboratories all the time, and they test new products and develop new products and new pharmaceuticals. And so this is a field on its own. Biologists are required to also understand chemistry. Non-chemists and non-biologists are required to know a little bit of chemistry. So it's a field that exists everywhere around us. Our first learning goal is to define the term chemistry and to identify substances as chemicals. What is chemistry and what are chemicals? So chemistry is the field that studies number one, the composition of matter, number two, the structure of matter, as well as the properties, number three, and the reactions of matter. And what is matter? Matter is another word for all the substances that make up our world. Example, water, glass, air, metal, all of these are examples of matter. So again, this field studies the composition of matter. What is that matter composed of? What are the constituents of this matter? What is the structure of this matter? What are the reactions of this matter when it's in contact with something else? An example here is the antacid tablets that undergoes a certain reaction when it's dropped in water. A certain gas is released when it reacts with water. So this is an example of a chemical of matter that undergoes a chemical reaction that the field chemistry studies and analyzes. Chemicals are often substances that are made up by chemists. They are manufactured by chemists, and that we use them every day. An example is the toothpaste, and it's a combination of many chemicals. These chemicals are substances that no matter where you find them, they still have the same properties as long as they're composed of the same constituents, and they are manufactured by the same companies. They actually have the same constituents, therefore they have the same composition and properties no matter where you find them. An example of the chemicals that constitute the toothpaste, or that are major components of the toothpaste. Here's a couple examples: calcium carbonate, sorbitol, sodium lauryl sulfate, titanium dioxide, and all of these chemicals serve a specific function in the toothpaste. For example, calcium carbonate, it's used as an abrasive to remove plaque. Sorbitol, it prevents the loss of water and the hardening of toothpaste, etc. So we can see each chemical has been designed, has been manufactured, and it has been included in the components of the toothpaste to serve a certain function. Chemicals are also all around us in the kitchen, for example. The glass of the window, it's made up of silicon dioxide, which is a chemical. The propane gas that we use in our ovens is also a chemical. It's a natural gas. Fruits are grown with fertilizers and pesticides, chemicals. So chemicals are everywhere in our lives. Throughout this chapter and the future chapters, we will always have sample questions for each section that we cover, just to make sure that we understand what we talked about before. And it's kind of like a study check for us to make sure that we understood the concept that we covered before, that we just covered. This sample question will ask the following: which of the following contains chemicals? So A, sunlight, B, fruit, C, milk, D, breakfast cereal. Now I advise you to take a minute and think to yourself about the right answer before we move on to the solution slide. Pause the video and think for yourself and try to figure out on your own before you look at the solution. Now, so which of the following contains chemicals? Option A is sunlight. Sunlight is not composed of matter. Sunlight is energy, therefore it does not contain chemicals. Fruits are an example that we just mentioned in the kitchen. It is a type of matter and it does contain chemicals. Milk is another type of matter. It contains chemicals as well. Breakfast cereal is a type of matter and it contains chemicals as well. So options B, C, and D are all correct, and they contain chemicals, whereas something that is not composed of matter, an example, sunlight, which is energy, composed of energy, therefore that does not contain any chemicals. Now, scientific method is our second topic in this lecture, and it's important to understand the basic principles of a scientific method and the components of a scientific method, and think like a scientist. This is what scientists adopt. They adopt the scientific method to explain certain observations that they see in the laboratories when they're designing new products, when they're designing new experiments, when they're discovering new theories. So they follow the scientific method, and because it is composed of components that are very important in the scientific process. Thinking like Linus Pauling is thinking like a scientist who has adopted the scientific method that allowed him to discover the things that he discovered, and he got and winning the Nobel Prize in Chemistry in 1954. The scientific method is composed of four major components. The number one component is making an observation about something that you see, and you see something happening. For example, we saw that when we put the antacid tablet in the water, it caused foam, and it also generated little bubbles, little gas bubbles. So this is an observation. We see that happening, but we don't know why. And then the second component, the second step, is propose a hypothesis, which is basically a tentative explanation to what is happening. What's the reason for this observation? What's the reason for this reaction in this specific case? We can say that Possibly the antacid tablet is composed of certain substances that would react with water and would produce gas. This is a possibility. It's a possible explanation. It might be right or it might be wrong. In order to prove it right or wrong, what we do is we carry out several experiments. Number 3 component of the scientific method. We carry out several experiments that we can that either have the same controls or same variables, either in the same way. We have to repeat them in the same way, so under the same conditions, and look at the outcome, and then we could possibly change one variable and repeat it multiple times. But to keep it simple, we take that glass of water and we put the antacid tablet again, just to make sure that it just didn't happen just with that tablet, that it's going to happen with every tablet. And we see, is it the same observation? And then we carry out more experiments to see if we are getting the same result, and if we're changing one thing, what are we getting? If we're changing another, what are we getting? Let's say we put it with a soda, or let's say we put it with tomato juice, what would happen then? So we do all of these experiments to prove our hypothesis or deny our hypothesis. And when a result of the experiments, when the experiments are analyzed, a conclusion is made. So we come up with the right conclusion that might prove the hypothesis, or it could deny the hypothesis. So here's an example about using the scientific method. Suppose you visit a friend in her home, and soon after you arrive, you begin to sneeze. Now you observe that your friend has a new cat. That's your number one. That's your number one step of the scientific method, observation. Number 2, you ask yourself why you are sneezing, and you form a hypothesis that you might be allergic to cats. You perform experiments to test your hypothesis by visiting other friends with cats. Now, if you go and you visit your other friends who have cats and you continuously sneeze, then you come up with a conclusion saying, okay, then maybe I am allergic to cats. If you go to another house that does have cats, but when you're around the cat, you don't sneeze, then your hypothesis is wrong, because either you are allergic or not. So through your observations, you may determine that you are allergic to cat hair and dander, or you might not. Sorry. So in using the scientific method, as we can look at this scheme over here, we can see that the hypothesis can be modified if the results of the experiments do not support it. Let's say that the conclusion, or after we repeatedly carried out several experiments and we came out with a conclusion that does not support the hypothesis, we can go back, or that does not support one component of the hypothesis, we can go back and modify the hypothesis and then do the process again. So the scientific method develops conclusions using observations, hypotheses, as well as experiments. Here's another sample question, and in the sample question you will be asked to identify each of the following as an observation, or a hypothesis, or an experiment, or a conclusion. If we look at option A, during your visit to the gym, your trainer records that you ran for 25 minutes on the treadmill. Number B, option B, scientific studies show that exercising lowers blood pressure. Option C, your doctor thinks that your weight loss is due to increased exercise. So try to think about this question to yourself, pause the video before you look at the next slide. So let's look at option A again. During your visit to the gym, your trainer records that you ran for 25 minutes on the treadmill. So your trainer was simply just observing you run on the treadmill, and he recorded that you ran for 25 minutes. So there is no explanation, there's no tentative explanation, there is no conclusion from this statement. It was simply just an observation. So the correct answer for this option, it's observation. Option B states that scientific studies show that exercising lowers blood pressure. Now in this statement, it's a statement. it's a result of a scientific study. In this statement, it was not an observation. It does not have any link to something being observed. It states that studies show that exercising lowers blood pressure. So it's a concluding statement. It's a result. And in this result, we do see that it's a fact. So there is not a plausible explanation. There's not a possible explanation or a tentative explanation. If it was, then scientific studies might show that exercising lowers blood pressure. Therefore, it could be true or not true, but this statement is stated in a way that it's a fact, which means that it's a conclusion. Option C, on the other hand, your doctor thinks that your weight loss is due to increased exercise. So he thinks that you might, your weight loss might be due to increased exercise. That might be true or not. He's not really 100% sure that it's due to increased exercise, and therefore this is a hypothesis. So we've learned about the field chemistry, what chemistry is, about chemicals, and about matter. We've defined matter. We have looked at the scientific method. We have identified the 4 major components of the scientific method. Observation is number 1. Stating a hypothesis is number 2, which is a tentative explanation. Number 3 is repeating the experiments multiple times under the same conditions or different conditions, just to see if you get the same outcome or the same result, and then which leads you to the last step, which is the conclusion. And in the conclusion, what you're looking at is basically you're looking at your outcome and you're finalizing the results, you're finalizing the explanation to why this is happening, to why is this observation, why am I observing this, what's happening. So your conclusion is stating the fact, it's stating that either your hypothesis was right or wrong. The last topic of this lecture is learning chemistry and the right studying strategy or the proper study plan for you to learn chemistry efficiently and be able to succeed in the field. We are going to learn how to develop a plan for learning chemistry, and I highly advise you to study in groups, because when you study in groups, some of you might grasp an idea better than the other, and if you study in groups and you share your abilities, some of you will help others and provide input that will be very helpful for you when you are studying. So I advise you to form groups if you can and meet once a week or twice a week, solve some practice problems, ask questions, and you are always welcome to ask me questions. Email me, or we'll meet during our advising times, or we'll schedule a time that works best for you and me, and we will go over any concept that you do not understand or you did not grasp in the lecture. It's very important for us to adopt a study plan that will lead us to success in this course. Now, the text features that will help you study, there are many different features in the book that throughout the chapter that are very helpful that you should take advantage of when you are reading the chapter. The periodic table is one which we are going to use later on. Tables, looking ahead chapter, glossary and index, key math skills, end of text, beginning of each chapter, inside back cover, inside front cover. Look at all of these features and take advantage of them, because they help you to organize your knowledge, to check your knowledge, to make sure you understood it or not, or to highlight the major key skills that you are learning, or the major chemistry skills that you are learning. So it's a way for you to organize your information in your head as well. At the beginning of each chapter, there are key math skills and core chemistry skills that are highlighted. The key math skills from previous chapters to help you understand chemical calculations in this chapter, what you will need to know for this chapter, and core chemistry skills from the previous chapters that are related to the chapter. So they're kind of providing you with a transition, the links that you need between the previous chapter and this chapter, the skills that you need to have from the previous chapter that you will need to use in this chapter. Now, before you begin to read the chapter and before you begin to study the content of each chapter, obtain an overview of the chapter by reading, looking ahead, to know what you are expecting, to know what is that you are going to read and learn about today. Look at the section title and rephrase it as a question. Review the learning goal that tells you what to expect in that section. And as you read the chapter, try to answer the questions you made from the section title. Work through the sample problems. I highly advise you to work through the sample problems step by step so you can follow the strategy on how that problem is solved, and you can adopt that strategy for other problems that you will be tested on or that you will solve in your problems at the end of each chapter. Review the visual guide to problem solving. This is very helpful. I highly advise you to review that. And analyze the problem features, shows you how to organize the data in some word problems. Sometimes you might have a word problem and you don't know how to identify your given from the unknown that you're expected to calculate or report. So analyze the problem will help you to identify each component and write down your problem in a way that will make it easier for you to solve. Try the questions and problems as well that allow you to apply problem solving to the new concepts. Any concept, you're going to be introduced to many new concepts that you probably have not seen before. So take use of all of these features that are supplied to you, that are offered to you in your books, and they are there to help you. And throughout the chapter, there are tools also that help you connect the chemical concepts you are learning to real life. And I know that for most of us, we like to see that link. We want to see, why is it relevant? Why do we need to study this? And so the chapter helps us with that because it provides us with tools that allow us to connect the chemical concepts that we are learning, whatever topic we are studying, with health, with environment, or with clinical applications, so we can see how it is applicable to real life. Figures and diagrams are very helpful as well. For a lot of us, we are visual learners. We like to see things, and so many figures will use the micro to macro illustration in order to depict the atomic level of organization, illustrate concepts in the text, allow you to see the world in a microscopic way. So they will try to scale things down to you and allow you to see it in a microscopic way, as if you're looking through a microscope. Also, I advise you to take advantage of, or take the time to look at figures and diagrams and study them and be able to identify the different components of a figure or a diagram. At the end of the chapter, there are also additional study aids there for you, such as the chapter review. So after you've studied the chapter, go back to the chapter review and test yourself on the basic topics that you studied in the chapter or the basic chemistry concepts. It provides you with a summary, and I know for me a summary is very helpful. Concept maps, it shows the connections between the different concepts. So for some of you who got lost in the transition from one idea to the other, it's helpful to go to the concept map because it allows you to link between different. So concept maps help you with that transition, and they help you with forming the connections between different concepts. Key terms. Key terms, you're going to be introduced to a lot of new terms. And molecules, matter, chemistry, chemicals, all of these are key terms that if you take advantage of the key terms feature at the end of the chapter, it would help you to refresh on the definitions and to know repeating information is always very helpful. So if you go back and you look at the word and you look at the definition, it would help you for it to remember it again. Understanding the concepts is also another feature which will help you to visualize concepts, because some of us are visual learners, so take advantage of that tool. Additional questions and problems and challenge problems are always advised, are always recommended to be solved. It provides a means to assess your understanding. So students are active learners, continually interact with the chemical ideas while reading the text, working the problems, and attending lectures. Always ask questions. If you do not comprehend a certain concept that I explained in the lecture, do not hesitate to email me or post a question online, or come to office hours and ask for help. I am here to help you succeed and to make sure that you understand every single concept that I explained. If you have any questions, again and again, I keep stressing, ask for help regarding any topic. We're here to help you and guide you to succeed. So my study plan for learning chemistry will include the following. This is my advice for you. Read the chapter before lectures. So it's helpful to have an idea of what the lecture is going to be about if you read the chapter before. Watching the lectures and being an active learner in the lectures, take notes. Pause the videos, take notes if you need to. When we come across a sample question, pause the video and try to answer the question on your own before you give me the answers, or before you look at the answers. You're not giving me the answers, but you're looking at the answers. And so before you do that, take a minute and try to answer it on your own. Review the learning goals. Keeping a problem notebook. Always try to solve as many problems as you want, or write down a concept that you didn't understand that you need to go over again, or you need to ask your instructor again. So read the text as an active learner and work questions or problems at the end of the chapter. Also, as I said before, organizing a study group will be very helpful. Team up with your classmates and share your knowledge with them, share your weaknesses and your strengths, and they will help you to clarify certain concepts that are misunderstood. Seeing the professor during office hours, as I emphasize on that, will be very helpful. Attend review sessions, organize review sessions, and study often. Chemistry, it's not an easy subject. It's a subject that requires you to put time and effort in order to succeed. So I highly advise you to go over the lectures multiple times if you have to, and solve as many problems as you can. So here's a sample question for what we just talked about. Which of the following activities should be included in your study plan for learning chemistry? Skipping lectures, forming a study group, keeping a problem notebook, reading the text as an active learner. Let's look at the answers. Of course, I do not want you to skip lectures. I want you to make sure that you watch each lecture and learn and actively engage in the lectures by writing down notes, by solving a sample problem on your own if you want to for a specific topic. Forming a study group will definitely be helpful. Keeping a problem notebook, of course, will help you to organize your concepts and to write down anything that you didn't understand and that you need to go back to and read again over. Reading the text as an active learner, definitely that will help you to remember and understand concepts. Now, key math skills for chemistry we do need to review some key math concepts used in chemistry. We will be required to know those these concepts for this course. Place values, positive and negative numbers, percentages, solving equations, interpreting graphs, writing numbers in scientific notation. These are skills that we will need to know throughout. We will need to learn and know throughout this course. And if we have any difficulties with any of these concepts, for some of you who do not have a math background, or if it's been a while since you've had math, I highly advise you to ask questions, and I am willing to explain and simplify math concepts for you to easily grasp it and understand it. For example, here's a graph. A graph represents the relationship between two variables. The first variable is the y-axis, which is the volume, and the second variable is on the x-axis, which in this case is temperature. So we can see that there's a relationship between volume and temperature that is represented or demonstrated by this graph. As the temperature increases, we notice that the volume of this balloon also is increasing. Identifying place values is the first key math skill that we will be talking about. For any number that we can identify, we can identify the place value for each of the digits in that number. What does that mean? The place values for two numbers are listed below. We have two examples. A premature baby has a mass of 2,518 grams. A silver coin has a mass of 6.407 grams. So, how will we identify the place value of these numbers? We look at this number. The number 2 is in the thousands place. It's 2,000. Number 5 is in the hundreds place, 500. Number 1 is in the 10th place, 10, and then 8 is in the ones place. If we look at this number, 6.407 grams, which actually is a decimal. It's not a whole number, it's not an exact number, it's a decimal number. It's a number that has a decimal. Number 6 will be in the ones place. Number 4, which is right after the decimal, will be in the 10th place. Number 0 will be in the hundredths place, and then number 7 is in the thousands place. So it's important for us to know these very well. Know always that when we start with an exact number, the first one will be the largest one, and then as we go to the right, it will decrease. For example, we started with 1,000, then a 500, then a 10, and then a 1. In this case, it will be the same if it was before the decimal. If we look at before the decimal, we identify it as, for example, in this example, 6 is identified as 1. If we had 26, 2 would be tens, and then 6 would be ones. If we had 266.4, 266, the 2 will be in the hundreds, 6 will be in the tenth, and then 6 will be in the ones, and then we will move on after the decimal as we did it here. Always after the decimal, the first number after the decimal is in the 10th place, the second number after the decimal is in the hundredths place, the third number is in the thousands place. Using positive and negative numbers, we are going to encounter positive as well as negative numbers. A positive number is any number that is greater than 0 and it has a positive sign. Often the positive sign is understood and we usually don't write it. If we wrote 1, it's just simply plus 1, but we don't write +1, we write it simply as 1. A negative number is a number that is less than 0 and it's always written with a negative sign. So to differentiate between +1 and -1, +1 we can write it as 1, but -1 we cannot write it at 1 because that will be 1, so therefore we have to write it as -1. Multiplication and division, positive and negative numbers. We will definitely need to also be very well skilled with multiplication and division because we will encounter that in the future chapters. When two positive numbers or two negative numbers are multiplied or divided, the answer is always positive. If you multiply 2 times 3, it will give you +6 because 2 is just simply +2 and 3 is +3. So this is a multiplication of two positive numbers, which gives you a positive number. If you multiply -2 and -3, you also get +6. So the multiplication of two negatives gives you a positive number, and the multiplication of two positives gives you a positive number, and the same applies for division. Now, on the opposite, when a positive number and a negative number are multiplied and divided, the answer will always be negative. If you are multiplying positive 2 or 2 by negative 3, then you are going to get negative 6. And the same applies for division.